Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is X bar chart and R chart for data evaluation in pharmaceutical manufacturing. These tools are important to establish the central tendency of the process and process width or process lower and upper specifications. Let us understand how these charts are compiled. It is very easy. You will get very useful information on data evaluation. Let us understand these tools. X bar chart, which is also called as mean chart, will provide the data on the mean or the average of the process. This chart revolves around the mean or average of a set of 4 or 5 consecutive samples. Central line CL will be calculated as average of each set of 4 or 5 consecutive samples. Central line is necessary to evaluate how the average of sample set moves around the mean. This is the purpose of the central line CL. Upper control limit UCL and lower control limit LCL must be calculated. For UCL and LCL calculations, please refer to my earlier video training programs. However, these formulas will be explained in the next slide again. R chart will provide data on dispersion or variability of the process. R chart is actually a range chart that evaluates on the range of the process. Simple way to understand is it is the difference between maximum specification and the minimum specification. In this type of chart also, it is necessary to derive the central line CL, upper control limit UCL, and lower control limit LCL. Please refer my earlier videos for detailed calculation and formulas for X bar chart and R chart. So in this case also the explanation will be given in the next slide. See this X bar chart carefully. This is a fabricated SA value of a product. It is all about the average of SA value of a set of 4 samples. There are 20 sets of 4 samples each selected. Average of each subset of 4 samples is calculated. Range is calculated as the difference between the maximum value and the minimum value in each 4 sample set. X double bar is the average of all X bars for 20 sets of 4 samples each. UCL and LCL are calculated using these formulas. The formula is X double bar plus Z, which is 3 sigma, which is 99.74% confidence, and standard deviation of the process sample was not more than 2%, and square root of number of sample sets, which is 4 in this example. The R bar is the average of all R values. This also is obtained by adding up of all individual range values and divide with 20. In this example, you get R bar value. The calculations for UCL and LCL are given here. Remember that the factor 2.28 is used for set of 4 samples for D4. For D3, it is 0 always. These figures are derived from statistical tables from internet. For a sample set of 5, the D4 value will be 2.11. It is adequate if you take 4 or 5 sample sets. Not more than 5 is generally not recommended. These are derived values for X bar charts with X double bar values and R charts with R bar values. See this chart. The information indicates that the average values are hovering over the central line most of the time. Process average seems to be acceptable. See this R chart. The values are dispersed widely around the central line. Though they are within the process width, there is no consistency in the SA values in consecutive batches. This can cause failure in SA at any time. This has to be corrected. Process parameters must be revised to see that the range values are around the central line. This can be observed in the data that was collected in the Excel sheet in the previous slide. By looking at the data sheet, it may be difficult to see this, but the R chart establishes well about this fact. This is another example of yield of a product ABC. The calculations of X double bar, R bar, UCL and LCL for X bar and R chart are same as explained in the previous example. Note here that the average is varying from 98% to 116% and the range values are nearer to the range of 35 to 40 in these cases. Let us see how this reflects on your X bar chart and R chart. See this chart. If the average variation is more, the spread over the central line is less. Closer to 50% values are on either side of the UCL and LCL. The process has to be modified to get consistent average yield. See this R chart. The range of 40 is reflected in the 4 values nearer to the maximum range. Though the product specification is within the process width of 40 kilos, it is necessary to tighten the process for consistency. I hope that these two simple examples will let you focus on evaluation of data using these useful tools that give you a very useful information on average and range. Let us try to understand on more such useful tools in next available opportunity. The data explained here is fabricated data. You may try with your original data. Your evaluation will definitely focus on several aspects of manufacturing process. Thanks for watching. For more videos, please do subscribe, like, and share. Also, please leave a message in comments box for any further support. Thank you.